doing log equations, and right now what we're doing is still talking about the earthquakes and the Richter scale. So pull that picture. Yeah. Okay. So, depending upon what they give us, you will have different approaches. So let's take a look at starting on example 3. So on December the 16th, a long time ago, an earthquake near New Madrid, Missouri registered an 8.8 on the Richter scale. Y'all, that's high. 8.8, that is very high. And then on October 17th, 1989, an earthquake in San Francisco Bay Area registered a 7.1 on the Richter scale. So we have 8.9 and then 7.1. So 7.1 is on the strong to major, but not near what the 8.9 is. All right, so it says, how much more powerful was the New Madrid quake than the San Francisco quake? Okay, so again, we're given New Madrid is 8.8 and San Francisco Bay Area 7.1. Now, when we first started learning about this, the magnitude is the number that they give us, but if we actually look at the strength of that earthquake, then we know that it's 10 to that power, right? So if you recall, the first thing that we want to do is think about what would that exponent be that we would place on that 10. Well, that deals with your Richter scale readings. So you would do 8.8 minus 7.1, which gives us what, 1.7? And this is your T, which is then your exponent. So we don't say that it is 1.7 times stronger. That's just what the exponent is. So then you've got to go to 10 to the 1.7. So calculate that and give me the 2 decimal places.
50.19.
50.1 what?
9.
9?
Or 2. Sorry.
Okay. 1, 2. Okay. All right. So this is how much stronger it was. Now, a lot that we talked about last week on this, it was either just 10 times as strong or 100 times. So now we're going to get into numbers that aren't just 10 or 100 or 1,000. So if it asked me to explain this, then I would say the New Madrid quake was 50.12 times stronger. Which is a lot, and when you go and look at that chart, I mean, this is still strong and major, but this is like, am I gonna survive level? Which that could be too, but this one really is. Okay, if an earthquake is 1,000 times as powerful, if an earthquake 1,000 times as powerful as the San Francisco earthquake occurred, what would its Richter scale measurement be? Okay, so we already know the Richter scale measurement for the San Francisco one, right? This one was 7.1. So what we want to do is find the Richter scale reading for one that's 1,000 times as strong. So I had a conversation with a student last week. This is, 10, 100, 1,000. So some can see it without showing this work that I'm going to. And they were like, do we have to show that? And I was like, as long as you tell me what your thought process was. So I'm going to go ahead and do it like I did last week. So 10 to some power is 1,000 times stronger. Right, because everything's base 10. Now, some of y'all could tell me right now what that 10 is, because you'd say, well, 10 to that power is 1,000. And if you can do it from there, that's fine. I'm gonna go ahead because they're not always gonna be that nice and neat. So if you recall, this is an exponential. So if I need to find this unknown, this is when we rewrite as a log. Okay, so from last week, logs are always equal to the what?
Exponent.
So I know this is gonna be equal to t. A log is always what base? 10. So we know the 10 and the t were taken care of. So this is where 1,000 would go. And now you can put that into your calculator. So log 1,000, and we get t equals 3. Okay, so this is t equals 3. Now remember, t equals 3, that is technically you're an exponent, right? But what this is the difference between the two. So to find the Richter scale reading. Now, this one that we're looking for, it's 1,000 times stronger. So should our answer be a number that is bigger or smaller than 7.1? Bigger, right? So San Francisco was 7.1, but this one is an additional 3 units on the Richter scale of magnitude. So it is 10.1 magnitude. I would not wish that upon anybody because that is off the charts on my picture here. 10.1, because this would go 9, 10, 11 and keep going. And that would be like the holy poo-poo emoji earthquake, right? All right, on December 26th, 2004, all right, an earthquake 100 times, or not 100, sorry, 80 times. So now we're not getting into base 10 here, right? So it's not going to be a whole number that we find here. Now it's 80 times as powerful as, and again, we know the San Francisco quake is 7.1. So this one's not as easy to see because again, we still would say 10 to some power equals 80 times as powerful. So now you are going to have to rewrite this as a log. So again, log of something equals the exponent t. We know log is base 10, so the 80 goes here. So we're not going to get a whole number like 10, t equals 3 in the prior one. So do log base 80, not log base 10 at 80. Give me 2 decimal places. What do you get?
1.99.
1.90? Okay, so again, it's 80 times stronger. So it's going to be a number that is larger than the 7.1. So it would be 7.1 plus 1.9. So we get a 9 magnitude. All right, I do want to just get this one started. All right, for certain decisions, the time it takes to respond is a logarithmic function of the number of choices faced. So in this one, they are giving us our function equation, and it's a log function where R is the reaction time in seconds and N is the number of choices. Okay. What's my function? What letter? You should be able to look at the equation and tell me that. R. And R is reaction time in seconds. my variable is going to be n, which is number of choices. All right, draw a graph of R versus N. Include values of N from 1 to 10 choices. Okay, so they want me to draw a graph, so my vertical axis is my function. So this is R. Reaction time in seconds. My variable N, number of choices. All right, how do I graph this? What do I do first? Do I have lists to plot? No, so I know I'm not gonna go to lists. What am I given? So where do I go? Y equals. We're given the equation. So I'm gonna do that equation. Now, look here, I'm gonna go ahead and turn my plot off because I don't have a list. And then I'm gonna put in my equation. That looks like that. All right, so after I put in my equation, what do we need to go to next? Here's your hint. Window. Your min is going to be 1 and your max is going to be 10. And then what? Zoom what? 0. List is zoom 9, list is zoom 0. Now I know my X minimum is 1, so I'm going to start at X at 1 and then that. All right, let's do B and we'll get started on your quiz. All right, express using functional notation the reaction time if there are 7 choices. What is given? Variable. So how do I write that in functional notation? Because it wanted this right here. So if you don't give that, you'll miss points. R at 7, and then it says calculate. So I'm going to take my equation 0.17 plus 0.44 times the log of 7. I went 3 decimal points, 0.542. And what does this number represent? Seconds, that's your function, so this is seconds. So it asked for this and this. Okay. All right, that's where we're going to stop today.